Section 2.6 Miscellaneous Equations. In this section, we're going to solve equations that are neither linear nor quadratic. Up to this point, all the equations that we've solved have been either linear or quadratic. So today, in this section today, we're going to take a look at different types of equations. So let's start first with equations with radicals, equations that have radicals in them. So how do we solve these? The first thing you do when you have equations with radicals is you isolate the radical term. So we isolate the radical term. Okay, and then depending upon the radical, you raise both sides to the appropriate power. So you raise both sides to the appropriate power. Okay, and then the last thing we have to do always is check your answers. So I'm not going to write that right now. Well, I should, because you should check your answers. So when we're solving equations with radicals, we always want to isolate the radical term. Okay, so we want to isolate the radical term, then we want to raise both sides to the appropriate power, and I'll show you what I mean by that. Because it's an equality, whatever we do on one side, we want to do on the other side. Okay, and we want to check our answers. We especially want to check our answers if we raise both sides to an even power. So if you raise both sides to an even power, we definitely want to check our answers, and you'll notice why when we do an example. Okay, so these are the steps you follow when you're solving equations that have radicals in them. So let's go ahead and take a look at an example and see if we can solve one of these. Okay, alright, so here we have an equation. We have y plus square root of y plus 4, y minus 4 is equal to 4. Okay, so this is the equation we have. So let's go ahead and take a look at it. It has a radical in it. It is an equation. It has a square root in it. Okay, so the first thing we're going to do is we're going to isolate the radical. So we're going to move this radical to the opposite side and the 4 to the other side. So we get y minus 4, okay, is equal to the square root of y minus 4. Okay, now what did the step say? Raise both sides to the appropriate power. What we want to do now is get rid of this radical. So if you recall from the section on radicals, if I have square root of b, for example, that's the same thing as what? B raised to 1/2, correct? So to get rid of this 1/2, I'm going to basically square this, because when I multiply that I get b. Okay, so what we want to do is basically negate that radical, and to get rid of that radical, because the radical changes to an exponent, 1 and 1/2, we can raise it to 2, because 1/2 of 2 is just 1. I'm sorry, half of 2 is 1. Okay, so that's what we want to do. So in this case, we're going to square both sides, and because we're doing it on one side, we're also going to do it on the opposite side. Now since we raised both sides to an even power, I need to check my answer, so I'll just put a note here, check solution. That is something you should always do. When you raise it to an even power, we always want to check our solution. Okay, so over here, our goal was to get rid of the radical, because I want to solve this equation for y. One of the y terms is inside the radical, so my goal should be to get rid of the radical. So the way to do that is you isolate the radical, which we did, and then we squared both sides to negate that radical. Okay, and you can see that also if you don't follow this, you can think about, for example, if I have square root of square root of 5 squared. Okay, that basically means what? You want to take square root of 5 times square root of 5. So you end up with square root of 5 squared. The power and the index are the same, so if you remember the property of radicals, that negates it, so we just get 5. Okay, and that's what we're doing. So whatever the index is of the radical, you raise it to that power is basically what you do. Okay, alright, so now that we did that, let's go ahead and take care of this left hand side. This left hand side looks a lot like a minus b the whole squared, binomial squared. If you recall, I gave you that formula in the last chapter. What does that mean? You square the first term, then you take minus 2 times the first and the second term, plus you square the second term. If you remember this formula, okay, if you don't remember this formula, then to do this you can take a minus b times a minus b, and you can do it on the side, and you can multiply this out, and whatever you get will go here. Okay, so it's up to you how you want to do it. I'm going to use the formula. So it tells me to square the first term, so I get y squared. Then it tells me to multiply the first and the second term, so I get 4y, and multiply that by negative 2. So 4y times negative 2 is negative 8y, and then you square the last term, so we get 16. Okay, over here when I square the radical, I'll just get what's on the inside of the radical. You can see that over here, we've shown that. Okay, so that's what we end up with. Now it's a quadratic, you guys can see that, so I want to move everything to one side, so I get y squared minus 8y minus y plus 16 plus 4 is equal to 0. So I get y squared minus 9y plus 20 is equal to 0. So now I can solve this either by factoring. If I can factor it, I can use a quadratic formula, or I can do completing the squares. But I know this one can be factored. It's got 3 terms, nothing in common, degree 2, so I can use the AC method. Leading coefficient is 1, so it's easy. Y, and 20. I want two numbers. When I multiply, I get 1 times 20 is 20, and when we add, we get negative 9. So the numbers are negative 5 and negative 4, because negative 5 times negative 4 is positive 20, and then negative 5 plus negative 4 is negative 9. So now we know this product is 0, so that tells me what? One of them has to be 0, so y minus 5 is 0, so I get y is equal to 5, and y minus 4 is 0, so we get y is equal to 4. Now remember what I said, we made a note here, right, to go back and check our answers, and it's very important to do that. Anytime you raise both sides to an even power, it's something you should automatically always do. Okay, so let's go ahead and do that. So y is equal to 5. If you want, you can use your calculator to check your answers like I showed you, or you can just do it really quick over here. Okay, when y is 5, what do we get? We get 5 plus, we get 5 minus 1 is 1, square root of 1 is 1. 5 plus 1 is 6. Is that equal to 4? No. That tells me right away that y is equal to 5 does not work. How about y is equal to 4? Let's check that. Y is 4 plus, we get 4 minus 4 is 0, square root of 0 is just 0. Is 4 plus 0 equal to 4? Sure it is. So in this case, the answer is y is equal to 4. So that's how we do problems with radicals. We always isolate one of the radicals and then raise it to the appropriate power to get rid of that radical, and then we solve the problem. And once we finish, we always check our answers anyway, but especially when we raise it to an even power, we have to check our answers. Okay, let me do one more example. Okay, so let's say that if I have 1 is equal to x plus square root of 2x minus 3. So let's go ahead and solve this. I have an equation that has a radical in it, so our goal is to get rid of the radical. So let's do that. The first thing we do is we isolate the radical. So I'm going to move this x to the other side, so I get 1 minus x is equal to square root of 2x minus 3. Since the index of the radical is 2, I'm going to raise both sides to 2, so I get 1 minus x squared is equal to square root of 2x minus 3 squared. And because we did that, we're going to have to check our answer, so let's make a note. Check answers. Why are we doing that? Check solution. We're doing that because we raise it to an even power. If this was a 3, then I wouldn't have to worry about that. Okay, so let's do this. This is a binomial squared again, just like I showed you earlier. So let's do that. You square the first term. 1 squared is just 1. Then you multiply the first and the second term, so you get 1 times x is x, and you multiply that by negative 2, so you get minus 2x. And then you square the last term, so you get plus x squared is equal to, when you square the radical, you just get the inside. So this is what we get. So now we have a quadratic equation, correct? So we move everything to one side, so you get x squared minus 2x plus 1 plus 3 is equal to 0. So we get x squared minus 4x plus 4 is equal to 0. It's got three terms, nothing in common. Degree 2, we can use the AC method. X is equal to 0. There's a leading coefficient of 1 here. Remember, we could also use a quadratic formula for these problems. We are not limited to just using the AC method, but in this case the AC method works just great. So we want two numbers. When we multiply, we get 4, and when we add, we get negative 4. So the numbers are negative 2 and negative 2. Okay, so let's go ahead and finish solving this. So we get x minus 2 is 0, so x is equal to 2, and we get x minus 2 is 0, so we get x is equal to 2. So we get the same solution twice. Okay, since we squared both sides, we should go back and check our answers. So let's do that. So here's my problem. Okay, so I'll just do the left side is 1, I just need to do the right side. So I have x, so that's 2, plus the square root of 2 times 2 is 4, 4 minus 1 is 3. 4 minus 3 is 1, so we get 1. Square root of 1 is just 1, so we get 3. Is 1 equal to 3? And it's not. That's not the case. So that tells me that this is not a solution, and since both the solutions are the same, neither is this, so this problem has no solution. Okay, so you really have to pay attention when you're solving these types of problems, because you're raising them to even powers. It can create problems with one solution. One of the solution doesn't work. We call that an extraneous solution, the one that doesn't work, like in the previous problem here. Okay, this would be an extraneous solution. But on the other hand, in this case, neither solution worked. Okay, now let's take a look at a problem where both of them work. So let's do one more problem. Okay, just to show you the variety here. So we have square root of 5x plus 6 minus 2 is equal to x. Once again, I have an equation with radical in it, so I need to isolate the radical. So I get square root of 5x plus 6 is equal to x plus 2. Because the index of the radical is 2, I'm going to raise both sides to 2. So we get 5x plus 6 squared is equal to x plus 2 squared. Okay, so now that I have that, let's go ahead and take a look at what happens. Out here, when you square the radical, we just get 5x plus 6 inside. This is a binomial squared, so we square the first term. We multiply the first and the last term, so 2 times x is 2x, and multiply that by 2, and since it's a positive, it's a positive 2. So we get plus 4x, and we square the last term, which is 4. Since it's degree 2 now, I'm going to move both of these terms to the right. So we get x squared plus 4x minus 5x plus 4 minus 6 is equal to 0. So we end up with x squared minus x minus 2 is equal to 0. Now, once again, we should be able to solve this easily because it's three terms, nothing in common, so we can use the AC method since it's degree 2. And the leading coefficient is 1, so that makes it easy. I want two numbers. When I multiply, we get negative 2, and when we add, we get minus 1. So the numbers are negative 2 and positive 1. Negative 2 plus 1 is that. So it's negative 2 and positive 1. So the product is 0, so it tells me x minus 2 is 0, so x is equal to 2. We get x plus 1 is 0, so x is equal to negative 1. So let's go back and check our answers in this case to see what happens. Okay, so the first one is 2, so up here, I'll just do it on the side here. If x is 2, we get 5 times 2 is 10, 10 plus 6 is 16, square root of 16 is 4, 4 minus 2 is 2, and x is 2, so that works. Okay, if x is minus 1, let me do it a little bit better. So we get square root of 5 times minus 1 is minus 5, plus 1 is 1, minus 2, and that's equal to minus 1. That's what it's, so then we get 1 minus 2 is equal to minus 1, minus 1 is equal to minus 1. So that's true. So in this case, both the answers work. So you can see the variety of problems we can create when we have equations with radicals. Okay. Now I did three examples of equations with radicals. They only had one radical. What happens when you have two radicals? So let's take a look at an example with two radicals. Okay. So I have square root of x plus 7 plus, minus square root of 3 minus x is equal to negative 2. Now, how did we solve a problem with one radical? What was our game plan? Our game plan was to isolate the radical term. Now, clearly I've said singular, not plural. I didn't say isolate the radical terms. So we want to still follow the same game plan. We want to isolate one of the radicals, not both, but one. So let's move this to the left, move this to the right. Okay. So we get square root of x plus 7 plus 2 is equal to square root of 3 minus x. Okay, so we're going to do that. Now our goal is to get rid of which radical? I want to get rid of this radical on the right hand side. So I want to, since the index is 2, I'm going to raise it to 2, and I'm going to raise this side to 2. Okay, now let's see what happens on the left here. This is a binomial. Even though it's complicated, it's this times this squared. So it's a binomial squared, just like we've been doing so far in the last 3 examples. Let's use a formula. It tells me to square the first term. So what happens if you square root of x plus 7 squared? If you notice, they will kind of negate each other. So we get x plus 7. Then we multiply the first and the last term, so we get 2 times this, and then we multiply that by 2, so we get 4 times that. So we get 4 times the square root of x plus 7. Then we square the last term, so we get 4. I do want to tell you, if you don't remember the formula, you could have easily taken x plus 7 plus 2 squared and written as at square root of x plus 7 plus 2 times square root of x plus 7 plus 2. You could have done this on the side. You could have distributed this, then distributed this, collect all the terms, and you would end up with this. So if you don't remember the formula, we can still do that. So don't forget those options you have. Out here, when I square the right hand side, we just get 3 minus x. Okay. Now we made progress. If you notice, you might think we didn't do anything. In the past, every time we squared both sides, we ended up with a quadratic, but in this case we didn't. But we did end up with something more interesting. We started with a problem that had 2 radicals. Now we are down to a problem that has 1 radical. So let's isolate that radical term and move on from there. So we have 4 square root of x plus 7. I'm going to move everything else to the right, so we get 3 minus x, that's already on the right. Then I'm going to move the minus x, minus 7, minus 4. So I'm moving these 3 terms to the right. So we get 4 square root of x plus 7 is equal to negative x times negative x gives you minus 2x. And then when you add all the numbers, you get negative 7 and negative 4 is negative 11, plus 3 is negative 8. So that's what we end up with. Okay. So what is my next step over here? What do I want to do next here? Okay. So let's take a look at what we want to achieve next. If you notice, I've told you once before, if you have an equality and then if you have something that's common in all the terms, like I have a number 4, 2, and 8. Okay. What I can do in that case is I can divide everything by that common factor and make my numbers smaller. What divides 4, 2, and 8? 2 does. So I'm going to do that. I'm actually going to divide by negative 2. That's because I have negatives here, so I'm going to do that. What is 4 divided by negative 2? I get negative 2 square root of x plus 7 is equal to negative 2 divided by negative 2 is just x. Negative 8 divided by negative 2 is positive 4. That's what I end up with. Okay. Always look for that. Anytime you have an equation where you have a common factor in all the terms, just divide by that term. Since it's an equality, you can do the left and the right. And we're only talking about numbers. If you notice, if I had x squared is equal to x, I can't divide both sides by x since there's an x on both sides. You don't do that. Just with numbers. So now we still have 1 radical left. Okay, so we isolated that radical term. So now let's square both sides again, just like we did before. Now out here we have to be careful, since I have a number in the front, so I need to square that. What's negative 2 times negative 2? Because you have to square that. So we get 4, and then we square the radical, so we just get x plus 7. I'm basically squaring each thing. I'm squaring this, I'm squaring this, because that's what the exponential property tells me to do. If you have ab raised to n, you get a raised to n and b raised to n. I squared this side. This is again a binomial squared, so I have to use the formula. I get x squared plus 8x plus 16. And this time I did it fast because I've done it 4 times already today. So you should be able to use the binomial formula. It's a quadratic. I need to move everything to one side, but before that I have to get rid of these parentheses, so I'll distribute the 4. So I get 4x plus 28 is equal to x squared plus 8x plus 16. Since it's a quadratic, I want 0 on one side, so let's move these two to the right. So I get x squared plus 8x minus 4x plus 16 minus 28 is equal to 0. Okay, so what do we end up with? We end up with x squared plus 4x minus 12 is equal to 0. We have 3 terms, degree 2, nothing in common. We can try the AC method. If that doesn't work, we can use the quadratic formula. So we have x, 0. I want 2 numbers. When I multiply, I get negative 12, and when I add, I get 4. So they are positive 6 and negative 2. The product is 0, so that tells me one of them has to be 0. So we get x is minus 6. X minus 2 is 0, so we get x is 2. So now remember, because we squared both sides a couple times here, we squared both sides here and also up at the very beginning, so we really need to check our answer. So let's do that. So my answer was what? 2. Let's start with 2. So if x is 2, I'm just going to erase here and you should be able to do this on the side in your notes. I just don't have room, so I'm going to do that here. If x is 2, we get 2 plus 7 is 9, minus 3 minus 2 is 1. So square root of 9 is 3, square root of 1 is 1, so you get 2. But that's not true. 2 is not equal to negative 2, is it? No. So that tells me 2 does not work. Okay, x is negative 6, so let's try that. X is negative 6, so negative 6 plus 7 is 1, minus 3 minus of minus 6, so negative and negative is positive, so we'll end up with 3 plus 6, which is 9, 1 minus 3 which gives you negative 2, and that is equal to negative 2. So this is a good answer here. So that's how we do problems with 2 radicals. So I've shown you some couple different examples here, problems with 1 radical, 2 radical, and also different variations and problems with 1 radical, whether we have 2 solutions, no solutions, or 1 solution. So please make sure you guys go back and check your answers, because we're squaring both sides in most of these cases. 2 is we're going to take a look at equations with exponents. So we're going to take a look at equations with exponents. So let me show you an example of that. Basically with this, before I show you an example, let's come up with a game plan. So the first thing we want to do is, if we have a rational exponent, okay, we want to raise it to the appropriate power to get rid of the rational exponent. Okay, so if the exponent, I'll abbreviate exponent exp, is rational, rational means fraction, then raise both sides to the appropriate power to get rid of the rational exponent. Okay, so that's the first thing we do. Alright, and then once we do that, okay, we can take the nth root to get rid of the power. So then use the nth root or the square root theorem. Remember the square root theorem from section 2.4? Square root theorem to get rid of the exponent or the power. I'll call it the power this time. And I know it sounds a little goofy right now, but as soon as I do one example, it'll make perfect sense. So let's take a look at an example. Okay. So let's say if I have x raised to 2/3 is equal to 4. Okay. You can see this is a rational exponent. Okay. So the first thing I want to do is get rid of that rational exponent. That means I want to get rid of that fraction. So I want to raise, since there's a 3 on the bottom, I want to raise both sides to 3. That's what I want to do. So I want to take x raised to 2/3 raised to 3 is equal to 4 raised to 3. You always try to get rid of that fraction first. Okay, and so that's what I'm trying to say. I want to get rid of that rational exponent, just the fraction part. Okay. So out here when you multiply this, when you have an exponent raised to an exponent, you multiply. So if you have 2/3 times 3 over 1, the 3's cancel, so you just get 2. So we get x squared is equal to 4 cubed is what? We get 64. Okay. Now that we did that, the next thing is we want to solve for x. So there's a square, so this is square and a number. This is the square root theorem we are using. So we basically do what? We introduce square roots on both sides, and when we do that, we always introduce plus or minus when we're introducing square roots. Square root of x squared is just x, so we get plus or minus 8. Okay. Now the question must be, you should probably ask me, should we check our answers? Okay. Well, we don't need to check our answers because we raised both sides to an odd power. So when we raise it to an odd power, we don't need to worry about that. They should work. But it's a good habit to always go back and check your answers either way. So you can use your calculators to check your answers. I've shown you how to do that. But we know that both the answers are going to work in this case because of we raised that to an even power. Let me do one more example of this. Let's say if you have x minus 1, okay, raised to negative 2/5 is equal to 4. Okay. Again, it's a rational exponent, so I want to get rid of that 5 first. Okay, and I also want to get rid of that negative too, because it'll make it easier to work with when we want to use the square root theorem. So I'm going to raise both sides to what? I'm going to raise it to minus 5. So I get 4 raised to minus 5. So when you multiply this, the negative and negative will become positive, the 5's will cancel. So we end up with just x minus 1 squared is equal to 1 over 4 over 5 because of the negative exponent. Okay, and that's something you can do on your calculator. Okay, so you'll end up with, if you did that on your calculator, you should end up with 4 raised to 5 is 1224. I'm sorry, 1024. Okay, so we get x minus 1 squared is equal to 1 over 1024. Now I want to get rid of the square. Since I'm solving for x, x is inside the square, so we have a square and a number, so we have to get rid of that square. So we take square roots on both sides. We've done that before many times. So you get x minus 1 squared is equal to plus or minus square root of 1 over this. So we get x minus 1 on the left. This gives me plus or minus 1 over 32, because square root of 1024 is square root of 32. And then the last step is you want to solve for x, move the 1 over, so you get x is equal to 1 plus or minus 1 over 32. So you can see that in this case we did the same thing as the previous problem. We first got rid of the rational exponent, the fraction part of it, and then we took square roots on both sides. Okay, I'm not done with this because this is over 1. I still need to add them. So I'm going to find the common denominator, which is 32. So we get 32 plus or minus 1 over 32. I'm hoping you guys know how to do that. You multiply the top and the bottom by 32 over here. So then we get two answers. If you use a plus sign, we get 33 over 32. If you use the minus sign, we get 31 over 32. Okay, so we get two answers. And you should check your answers. I know both of them are going to work because we didn't raise anything to even power. We actually raised it to the fifth power and also a negative number. So just keep that in mind, okay? So that's how we tackle equations that have exponents, okay? If you want, I can do another example just to show you guys that, but it's pretty much the same idea for all of them. Actually, when the next type of problem that we're going to take a look at, you'll come across these again, so hopefully you'll get practice then. So let's take a look at the last category, equations that are almost quadratic. Okay. Now the notes that you're using for this class, they call them equations that can be reduced to quadratic. That's the same thing, but I prefer to call them almost quadratic. Quadratic means degree 2. So what we have here is we have an equation that's not degree 2, but by making a simple substitution, I can make it into a degree 2 and then solve it like we did in section 2.4, either by factoring or using completing the squares method, or we can use a quadratic formula. So we can make them into quadratics. Okay, so let me show you how to check to see if it's almost quadratic. So here's my check. You should always perform this check to see if an equation is almost quadratic. What you do is you start by taking the middle term variable. So this is middle term variable, just the variable, not the coefficient or anything, just the variable squared. And if that's equal to the first term variable, then it's almost quadratic. Okay, so this would mean that it is almost quadratic. So this implies almost quadratic. So once we know it's almost quadratic, then we can make a substitution like I said. Okay, we make the following substitution. So we do this first, okay, then we do this. We we create a new variable, I'll call it z. Z is equal to the middle term variable. And that's it. So that's how we solve equations that are almost quadratic. So let's take a look at some examples, okay, and see how this method works. So here's the first example. I have x to the 6 plus 7x cubed minus 8 is equal to 0. Now clearly this is not a quadratic equation. You can convince yourself of that because the degree is 6. To be a quadratic, it has to be degree 2. So, and there's no other way to solve this, because normally if it's not quadratic or linear, we know how to solve those two, then my options are limited. We can either solve by factoring or nothing else. There's numeric methods, but for us there won't be any other methods. So how do I do this? Well, let's take a look at it. The first thing I do is, since I've got 3 terms, I should always check to see if it's almost quadratic. So let's do the check. You take the middle term variable, which in our case is x cubed, correct? Just the variable, not the number in the front, just the variable, and you square that. So if I square that, I get 3 times 2 is 6, so I get 6. Is that the first term variable? Sure it is. So that implies it's almost quadratic. So it passed the test for almost quadratic, so it is. So let's make a substitution. So we can go let z is equal to the middle term variable, so it'll be x cubed. And then I'm going to square both sides, so I get z squared is equal to x to the 3 squared, which is x to the 6. Now why did I do that? The reason for that is because now this tells me that in my problem I can replace x to the 6 with z squared and x cubed with z. So let's do that. So this problem that I started with will become x to the 6 becomes z squared plus 7 x cubed becomes z minus 8 is equal to 0. So you can see we have made it into a quadratic. That's the whole idea of almost quadratic. Okay, now we can solve this with all the different methods that we learned in section 2.4. I can factor this. So I'm going to do that. Z is equal to 0. I want two numbers. When I multiply, I get -8, and when I add, I get 7. Okay, so the numbers are what? +8 and -1. So now let's continue this. This product is 0, so one of them has to be 0. So z plus 8 is equal to 0. So I get z is equal to -8. And z minus 1 is equal to 0. So I get z is equal to 1. A lot of the time students are just thrilled to get the answer and they'll stop at this point. But we cannot do that because the problem we originally started to solve was to solve for x. Right now we just solved for z, not for x. So we have to change the z back to x. So what is z? X cubed. So I can replace my z over here with x cubed. So I get x cubed is equal to -8 and x cubed is equal to 1. Now how do I solve this? Well, if I had x squared is equal to a number, what did we do? We introduced square roots on both sides because we did the opposite of a square, which is a square root. The index is 2. So we got x is equal to plus or minus square root of that number. Remember to introduce plus or minus with even roots. In this case, because it's a cube root, I don't have to worry about the plus or minus, but I can introduce the cube root of this on both sides. This gives me x. What's a cube root of -8? Cube root of -8 is -2. And over here I introduce cube roots again on both sides. When we introduce cube roots, we do not have to worry about the plus or minus, only with square roots with even roots when the index is even. This gives me 1. So here's my answer. Okay. It's always a good habit to go back and check your answers. I can tell you that they're both going to work, but because of time, I'm not going to check them, but you should definitely take a few minutes and check them. Let's take a look at two more examples of this, and then we should be done with this section. We have x to the 4th minus 13x squared plus 36 is equal to 0. Okay. So once again, this problem is not a quadratic equation, is this? So what do we do then? Okay, it's degree 4, so it's not quadratic. So what we want to do then is we want to basically change it to a quadratic. But before we can do that, we have to check to see if we can even do that. Okay, so we want to make sure that we can do such a thing. So let's check it. How do we check? We take the middle term variable, which is just the variable, which is x squared, and we square that. So 2 times 2 is 4, so we get x to the 4. If that happens to be the first term variable, we're good. So this is almost quadratic. Okay. If you know it's almost quadratic, we need to make a substitution. So we can go let the new variable z equal to the middle term variable, x squared. Then I'm going to square both sides. So I get z squared is equal to x squared squared. So we get x to the 4. So this tells me to replace x to the 4th with z squared, and then z with x squared with z. So let's do that. So out here, this equation that I started with will become this. X to the 4th becomes z squared minus 13, x squared becomes z, plus 36 is equal to 0. So now we can easily go ahead and solve this by factoring. We don't need to use the quadratic formula. It's got 3 terms. We can use the AC method. I want two numbers. When I multiply, I get 36, and when I add, I get -13. Then -9 and -4. This product is 0, so that tells me what? One of them has to be 0. I'm factoring these problems fast because we spent a lot of time on factoring, and by now, if you've been doing your homework, you should be fine with it. Okay, so we get z is equal to 9, z is equal to 4. Is this a solution? I'm hoping you're saying no, because this is not the solution, because this is a solution to a problem in z. Our problem was a problem in x, so we have to change the z back to x. So what was z? Z was x squared, so this becomes x squared is equal to 9. We get x squared is equal to 4. How do we solve a problem where you have a square is equal to a number? we take square roots on both sides, and since we are taking square roots, we have to introduce plus or minus. So we get x squared is equal to plus or minus square root of 9. So we get x is equal to plus or minus 3. Out here we get square root of x squared is equal to plus or minus square root of 4. So we get x is equal to plus or minus 2. So you can see out here we got actually 4 solutions. Okay, plus 3 minus 3 and plus 2 and minus 2. Okay, alright. The next problem that I'm going to do, the last one, is this one. We have x minus 9 square root of x plus 14 is equal to 0. Okay, so let's take a look at this problem. Okay. This is degree 1. Okay, technically it's not even a polynomial because of the square root, because this can be written as what, x raised to 1/2. So it's a fraction. Remember, to be a polynomial, all the powers have to be positive integers or 0. So this is not even a polynomial. So let's see what we can do with it. We don't know how to solve this. It's got 3 terms. As soon as you see 3 terms and you don't know how to do any other methods, you should check for almost quadratic. So let's check. I take the middle term variable, which is square root of x, and I square it. If you take square root of x squared, we know you're just going to end up with x. Is that the first term variable? Sure it is. So that tells me that this is almost quadratic. So the next thing I want to do is make a substitution. So we can go let z is equal to the middle term variable, and then I can square both sides. So I get z squared is equal to this squared. When I square this, you just get x, because square root of x times square root of x is just x. So let's see now. What do? We replace x with z squared minus 9 and square root of z with z plus 14 is equal to 0. Now it's a quadratic, which is what we wanted. So let's just finish this up. I can solve this by factoring. I want two numbers. When I multiply, I get 14, and when I add, I get negative 9. So they're minus 7 and minus 2. So this product is 0. So what does that tell me? One of them has to be 0. So I get z minus 7 is 0. So I get z is equal to 7. And we get z minus 2 is 0. So we get z is equal to 2. Remember to change z back to x. So what was z? Square root of x is equal to 7. And we get square root of x is equal to 2. How do we get rid of a square root? We did a whole section on that, whole bunch of problems on that earlier today. To get rid of a square root, we isolate the square root and square both sides. So the square root is already isolated, so let's square both sides. So if you square both sides here, we get x is equal to 49. I do the same thing, square both sides, so I get x is equal to 4. And those are your answers. Now, you have to be careful, because we did square both sides, we should go back and check our answers, because we did square both sides here, don't we? So we should go back and check our answers to make sure that they work. So let's quickly do that. If x is 49, we have 49 minus 9 times square root of 49 is 7 plus 14, and that should all equal to 0. And you can do this on your calculators if you prefer. So we get 49 plus 14, we get 63. So we end up with 63 minus 63, because 9 times 7 is 63, and that is 0. So that works. So in this case, it worked fine. And the other answer was 4. So let's take a look at that. We have 4 minus 9 times 2, because square root of 4 is 2, plus 14. Okay. So we get 4 plus 14 is 18, minus 18 is equal to 0. So we got. Now, anytime you square both sides, you raise both sides to an even power, we should always go back and check our answers, especially for that reason. But in this case, both of them work. So we looked at a whole bunch of different types of equations. Make sure you guys practice your homework problems so you can master these concepts.